All right, this is our last core concept. We're not done yet, though. The power of a product property. This says that if I want to find the power of a product, that means you're taking the power of two things multiplied together or more. Find the power of each factor and multiply them. So 3 times 2 to the 5th power would be 3 to the 5th times 2 to the 5th. Now you may say, why can't I just take 3 times 2 and get 6 to the 5th power? Because these two numbers may not be actual numbers. They may be letters at some point. So in algebra terms, ab to the m power gives you a to the m times b to the m. The quotient power says this. To find the quotient, the power of a quotient, find the power of the numerator and the power of the denominator, and then you divide. So I could do, for example, 3 halves to the 5th power. I'd actually do 3 to the 5th power divided by 2 to the 5th power. So in the form of algebra, a divided by b to the m gives me a to the m divided by b to the m, where b cannot be 0. Example number 4, using properties of exponents. Simplify each expression. Write your answers using only positive exponents. So A, what we have to do here is you take everything to the negative 2 power. You take the negative to the 2nd power. You take the 1.5 to the 2nd power. You take y to the 2nd power. So I'm going to show you the long way. Negative to the 2nd power is just positive, even power. But really, this means you're doing this. You're taking everything to the 2nd power. Now, I would never normally make you do that. You should just be able to look at this and say, well, 1.5 squared, that gives me 2.25. And I take 1 times 2. So my answer is 2.25y squared. You should be able to go right from the problem directly to your answer. B, this would be dividing two numbers and a letter. So we have to actually take everything to the 3rd power. So this would give us a to the 3rd divided by negative 10 to the 3rd. That would give me a to the 3rd divided by negative 10 to the 3rd, which would give me negative 1,000. But we always put our negative on top or out front. So my answer would be negative a to the 3rd divided by 1,000. C, 3d divided by 2 to the 4th power. That means I would get 3d to the 4th power divided by 2 to the 4th power. That would give me 3 to the 4th power. 3 to the 4th power is 81, d to the 4th, divided by 2 to the 4th power, which is 16. I now simplify, if I can you simplify 81 and 16? You cannot. So to the d, I would take negative 2x to the negative 5th power, divided by 3 to the negative 5th power. Now I'm going to show you a shortcut. This is my shortcut. Actually, I'm going to erase that because I don't like this. The book doesn't teach it to you like this. I do. Since it's a negative power, flip the entire fraction. 2x, whoops, I didn't flip it. That would help if I flipped it. If I take the reciprocal, I get 3 divided by 2x, and then the power becomes positive. So then I would take 3 to the 5th power divided by 2x to the 5th. Notice that every time I have something with more than one term, I have parentheses around it. If you don't put parentheses, it will be wrong. Because if you don't put parentheses, like here, you're only telling me you're taking the x to the 5th. So if I simplify this, 3 to the 5th power gives me 243. 2 to the 5th power gives me 32. And x, I would take 1 times 5, and that gives me x to the 5th. I cannot simplify 243 divided by 32, so there's my answer. Here's some more examples if you want to pause the video. This one will become, I'm going to flip it over. That would become positive 3. That will give me 1 over 1,000 y to the 3rd. Number 12. I would take negative 4 to the 5th power divided by n to the 5th, and negative 4 to the 5th power is negative 1,024 divided by n to the 5th. Number 13, I would take 1 to the 5th power and 2k squared to the 5th power. That would give me 1 over, well, 2 to the 5th power is 32. I multiply my exponents, k to the 10th. Number 14, I would get, I'm going to flip the entire thing first. So that gives me 7 over 6c. And that would give me 49 over 36c squared. All right, we're having fun now. Solving real-life problems. Example number 5. You're going to simplify a real-life expression. Which of the following expressions shown represent the volume of the cylinder, where r is the radius and h is the height? So we have 6 possible answers that are down here. Let's figure out what the volume of a cylinder is. The first thing you do is actually show work. Write down the formula, which you should know, as pi r squared times height. So now we plug in what we know. Volume equals. Now notice that everything here is left in terms of pi. Since everything has pi in it, that means we are not going to plug in anything for pi. The radius we know is h divided by 2. So then we square the radius, and then we times that by the height. And now we just do some basic algebra steps. Simplify, using our exponent powers or exponent rules that we learned. So here I would take both the h and the squared, both the h and the 2 to the 2nd power. That would give me h squared divided by 4 times the height. Then I would actually take pi times, and now I multiply. H squared times h. Well, they're the same base, so what do you do with the powers? H squared times h gives me h to the 3rd divided by 4. So my answer would be pi h to the 3rd divided by 4. So it looks like this right here is my answer. But if you think that's my answer, and that's the only answer, you're wrong. This is where, as students in TAP, you must really look at what's given to you. This is the answer that we proved. But anything that is equivalent to this would also be my answer. So I have 2 pi r to the 3rd power. So let's look at this one. You're like, well, that's not the same thing. Maybe it isn't. But here's where the hard part comes into play. You know that h, the height, is equal to what? 2 times the radius, because we know right here the radius, here's what I'm going to do, the radius is equal to h divided by 2. If I actually multiply both sides by 2, that gives me the height is equal to 2r. So I could take this equation right here. The volume, what we got, volume equals pi h to the 3rd, all divided by 4. I'm going to use substitution. I know the height is equal to 2r, so I'm going to plug it in. That gives me v equals pi times 2r to the 3rd divided by 4. I'm going to simplify this and give myself some more room. So if I simplify that, pi times 2r to the 3rd divided by 4, well, that would give me pi times 8r to the 3rd divided by 4, which if I simplified 8 divided by 4, that would give me 2 pi r to the 3rd. So notice that is also an acceptable answer. So now we go to the next one. The next one, pi h to the 3rd, 2 to the negative 2. Oh, we have a red flag going up. I can't have 2 to the negative 2. So where does that go? It goes on the bottom. So that gives me pi h to the 3rd over 2 squared, which gives me 4. Oh, it's the same thing. That's also an acceptable answer. The next one, though, 4 to the negative 1, that would go on bottom. That would not work. This one is pi h to the 2nd divided by 4. That would not work. And this is pi h to the 3rd divided by 2. And that would not work. So you actually have 3 equivalent answers here. All right, our last example involves scientific notation, which you learned last year. Now remember, a number is written in scientific notation when it is in the form of a times 10 to the b. And a, this number right here, must be greater than or equal to 1, but less than 10. It cannot be exactly 10, but it can be exactly 1, and then anything in between. And b is an integer. So b is just like -5, -2, -1, 5, 7, whatever. So here's what we know. A jellyfish emits about 1¼ times 10 to the 8th particles of light, or photons, in 6.25 times 10 to the -4 second. How many photons does the jellyfish emit each second? Write your answer in scientific notation and in standard form. So, we're looking at this problem. I want to know how many photons for each second. That means I have to have photons per second. That means I write a unit rate. And you've done unit rates before. So I have to take photons per second. That means photons divided by seconds. I now can write that. This is just multiplication. So I could write it as 1.25 divided by 6.25 times 10 to the 8th divided by 10 to the -4, which involves all the properties that we've already done. 1.25 times 1.25 divided by 6.25 gives me 0.2 times. Now, I have the same base. Same base. What do I do with the powers? I subtract them. So that would give me 8 minus -4. And that would give me 10 to the 12th power. But that's not my answer. And here's the huge problem. This number is not between 1 and 10. I have to make it between 1 and 10. So as you know how to do scientific notation, I make the number between 1 and 10 by moving the decimal 1 to the right. That means if I move it 1 to the right, I only then have to multiply it now by 10, 11 times to get back to the answer of 200 billion photons per second. So you could say 200 or 2 times 10 to the 11th photons per second. And we also have to write it in standard form. Standard form means just a normal number. So 2 times 10, 11 times, gives me 200 billion photons per second. Now, we're actually done, but if you would like to do one more example on your own, you may do that, and here it is. It takes the sun about 2.3 times 10 to the 8 years to orbit the center of the Milky Way. It takes Pluto about 2.5 times 10 squared years to orbit the sun. How many times does Pluto orbit the sun while the sun completes one orbit around the center of the Milky Way? Write your answer in scientific notation. So we have to divide. Now the sun is a bigger number because we're taking 2.3 times 10 to the 8th. So we're going to divide 10.3 times 10 to the 8th divided by 2.5 times 10 squared. So let's divide this. 2.3 divided by 2.5, that gives me 0.92 or 92 hundredths, times, and now I have the same base. What do I do with the same base? When I divide, I subtract. So 8 minus 2 is 6. So 0.92 times 10 to the 6th. It's not in scientific notation because this number is not between 1 and 10. So we have to move the decimal to make it between 1 and 10. So that'd be 9.2 times 10. Here's the deal. I moved it to the right 1. Now, this is where some students get confused because they're like, Mr. Humphreys, I don't know whether or not this 6 needs to become a 5 or a 7. Well, if you get confused, do it this way. This is what I suggest. I'm going to rewrite 0.92. Just put that in scientific notation. And you've done this before, last year in 6th grade. 9.2 times, well, that'd be times 10 to the -1. Because 9.2 times 10 to the -1 means my decimal will go 1 to the left, which would give me 0.92. So then, I just add this on to the end, times 10 to the 6th. So that gives me 9.2 times 10. And same base, when I have the same base, what do I do with my powers? I subtract them. So that'd be 10 to the 5th power. So my answer would be 9.2 times 10 to the 5th power.